Hello, my name is Kevin. As indicated in the previous video clip, we indicated that during the setting of electronic circuit breakers, we need to do certain activities. Of course, it's much easier to possibly follow along when we do an actual example of that. So let's go to that slide set. And we're going to look today at some examples of two of the types. So we mentioned that all electronic breakers need to be set, and we indicated that we had approach to this. And what follows in this video setup is that we're looking at two actual air circuit breaker types, which give us a variation somewhat in what we actually see. So if we have a look at this particular practical demo on these, is we'll be looking at two Mitsubishi type air circuit breakers that have been on the market for many, many years and very popular. And the SBGT type relay is a previous model to the current WS1 model of the air circuit breaker. So we'll be looking at these relays and having some discussion on the actual values we see and what they mean. So without going any further, let's just quickly recap the 4 steps. We need to set the amp rating and the rating of the circuit breaker as the very first and most important step. We need to set the instantaneous trip values. We need to set the timing settings and any other options if they are in fact fitted on there. So these 4 steps give us the basic approach. And once we have a look at these, we can see in terms of the knobs that are there, what they are, and we can have some discussion on that. So as we discussed, the SBGT relay is from a previous range of Mitsubishi air circuit breakers. That's where you would see the title in there. We can also see that it was taken from a 2000 amp unit, but these electronic modules are common right throughout. So this indicates that the particular breaker this one was sourced from was a 2000 amp, but it could in fact be fitted to any of the amp ratings in that series range. And if you have a look following from the sort of the top down, we'll have a check at what we've got on the type of relay, and let's have a look at it. So it's got things like trip indicator, L, S, I, G, PAL out, and a reset. So if this unit did actually trip, you could reset them. On these type of relays, they are all self-powered. In other words, they require no external power to work fully, except for one function, and that is, should this air circuit breaker trip out, it will tell you what the trip value and what actually did or did not work in terms of why it tripped. In other words, it'll be a G, it will go down to the ground fault here. And it'll tell you and keep that light on. If you don't have a separate power system, the moment it trips, poof, it's gone. You lose all sight of it. A reset would just be a simple button to reset so that you could reinstate the breaker. We can also look, there's a bit of a bar-coded graph LED system here where it's indicating between 60 and 100%. And if it goes over, it will go and blink red prior to tripping. So it's going to take 10 seconds to trip out. While it's timing out, you're going to see that little thing. So it's almost like an ammeter and can be used quite substantially for that type of arrangement. Some of the units out there may start to hear about, if you look at this 90% to 100%, might in fact come up with orange. So it might be green, 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 orange, up to a point, and then go red the moment you go over it. So circuit breaker is not intended to be used continually at or around 100% of the actual value continuously. It'll start to possibly give you an orange warning, because if there was an inrush at that level, it could trip out at some point if it was sustained. So we said that we'd have to go to the first thing would be rated current. So if we have a look at, it says rated current, IN, and it goes 0.5 up to 1, which would indicate, if we ignore the 2000 amp for the moment, let's talk of a 1000 amp. It's much easier to think in terms of that logic. That would mean this device, this ACP, could be set between 500 amps and 1000 amps. In other words, half the value is typical as a value trip. So a substantial value variance available from a breaker. And as we said, if you are going to be running at 800 amps, set it at 800 amps if that would be secure in terms of where you would like to run. You will notice that some of these other values, where's one here? A limited time, they're not times, interrupted current might be times IN. So that's IN. These values are multipliers of that. So if this one's already high, all the others could be far out. Let's have a look. Okay, so that's the first step. We need to set the current rating. Let's also have a look at uninterrupted current rating. This is an additional type of feature. If you have a look here, it goes from 0.8 to 1 times that value. So this could be set at 800 amps on 1000 amp up to on a value here. So we could set this for uninterrupted current. It's not going to trip below that value. So it's never going to trip below 800 amps. Finished, that's it. But if we do the multiplication here, we can see that 0.8 times 0.5 gives us 40%. So the circuit breaker, although it's marked 1000 amp as we talk in our discussion here, can be set anywhere between 400 amps and 1000 amps, which is a huge range. And those are the two most prominent first step arrangement that we need to do. So we also need to have a look at an additional one, which the second step would be we need to have a look at the instantaneous value. So let's have a look here. So that is LI, instantaneous current. And we can see it goes from 4 to 16 times the same, which is linked to that. That's why it's so important that we do these adjustments. And this would always be the start of everything, because every other one almost is a multiplier of that. As we said, this we need to have a look at because it's hardly worth setting it at 16, and it will come out the factory set at 16. And you may not have the energy required to trip that on that level. So you need to do that pretty much as it comes out. Let's have a look at the next three. So, okay, so those are step 1 and 2. So it's 1 is those two on this particular relay. And then step 2 is this one on here. Okay, now just while we're at that level, we mentioned the load current here, and you can see the PAL. So this is the alarm value. You can set it to trip, you can set it to give you indicators. So you can actually adjust this at some value down to 70%. So you could say at 700 amps, I want the orange on, and they'll give me some idea I'm running into the end of this. So an advantage would be that if you set these, well, I would never set it that low, generally maybe 80% is a fairly common way of adjusting these. And that would say if you were in a shopping mall and over time, you always had green and now you're starting to get orange, it would indicate that your loads are slowly catching up with you and may one day become a problem. Step 3, we said we need to have a look at all timing type arrangements. So limited time, standard time, or what we're going to have a look here. Now, this is the part of the tripping curve. This is your overload time. So your limited time, in this case, goes anywhere between 12 and 150 seconds. It's S or seconds. And you can adjust it. So we said that if you don't even know where to set it, for goodness sake, don't just leave it on max. Max is for a full motor inrush type of arrangement. So 150, you'd set this somewhere between, say, at 50 and then leave it at 50. If you weren't sure, if there was very low risk of inrushes, you could choose lower. Bear in mind that you get no nuisance trips, and exactly the same here. So the same approach actually happens with this type of arrangement. You also see as observation here, there's some sort of test plug that goes in here. And of course, you can test these type of products in situ or back in the workshop. And you plug in a tester and you can actually prove that this product works at all the intended values. So most times the manufacturer would be more consistent in, is it working at all? Because most electronics fail, and then it's failed completely. It doesn't normally half fail and half the values change, stuff like that. It's either working or it doesn't. So products where you suspect a short circuit has, for instance, not tripped the breaker, you could approach the manufacturer to come and do that, or send the product back and say, please test. And from odd occasion, this type of thing would have maybe a failed controller type control module like this. All right, so next one is, sorry, let's just go back there. The step 4 would be having a look at alternative arrangements here. So let me, okay, step 4, okay. So step 4, if you have a look, so what have we not had a look at? So we got GFR, it says trip, alarm, ground fault time, blah, blah, blah. So let's have a look at that. So GFR is an earth leakage type of operation. In other words, it's using internal CTs in this case, and you get it as a benefit. Now, straight away, you can see, you can either, if this allows to work, you can either trip the breaker or you can get a pure alarm. In other words, you can have a siren alarm built in, and the siren alarm or the indicator will tell you you've got a ground fault situation, and I'll give you an alarm. It's quite the nominal thing to actually use this because it's for free. I mean, it's a ground fault arrangement here. The ground fault just being a very coarse earth leakage. In other words, if I have a look here, it goes from 0.1 times IR or IN. So it's from 10% to 50% of the value. So 10% on 1,000 amps, if it was left at all, it would be from 100 amp to 1,000 amps. So that's pretty coarse earth leakage, but there are advantages is that obviously the biggest short circuit level risk is phase to phase. But if it goes down to ground, that operation can be made to pull out the circuit breaker faster than waiting for a current-based trip. So we could put it on trip and we can adjust it here. I mean, yeah, okay, 10%, 100 amps is quite an earth fault. But if it touches ground at 100 amps and flows to ground, it'll trip. Whereas between maybe phases, you're talking about something a lot higher. And then you can also set the time. So you might be able to, if you had to grade 2 breakers in a row as a series connection, you might put one a bit higher backstream and one lower downstream, and you can adjust the actual tripping time. Rather a nice arrangement to do there. The other thing is you see instantaneous and MCR, and instantaneous would be an immediate trip. And MCR is a device inside this unit which blocks the setting for maybe 2 or 3 cycles. And that's again for motor. So this would be non-motor and motor use. And bear in mind that when this is being used, it's 1 motor per arrangement. So there's a lot to understand in a little simple relay. To get it right, you need to understand what every one of those little knobbies is doing and how you approach it in the same concept. So the 4-step approach works fine on here. And this, as I said, is the Mitsubishi style of relay for the ACBs, which are probably 20 to 30 years max age-wise. Also of note, I don't know if you use the same here for Mitsubishi, is a WS1 relay, which when you look at the relay looks considerably different to the other one. But he's fitted to also, again, Mitsubishi brand of product. And other than the relays, there's very little difference. So understanding these 2 relays possibly gives you a good idea of the 4-port approach where the relays look totally different. So again, let's have a look. And in this case, it doesn't really go top down. It goes from the side here. While it's running, it'll have a green on there. If there's some sort of error on it, it'll give you an error message. Again, your little bar graph arrangement in here. And we can see here that that is linked to IP. In this case, it's the actual barcode indicator. And again, I can't quite read it, 0.6821. So that'll give you some idea here of going again, green, 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 orange, and then red before it trips. It'll time out and then trip. So again, as we can just observe here, there is a reset button if we have to reset after a trip. Again, a test port. Again, the same tester gets used. And so let's go back to this. We said step one, we got to adjust the rating. So IR, rating in this case, times IN. And if we have a look at what IN is, again, this would come universally fitted to a product. So let's talk about 1000 amp again. It goes 0.5 to 1. So that would go 500 to 1000 amps. That's important from that avenue. We have IU, which is again a portion. So this can be set if you have a look here, 500, 550, 600, 650, 700, etc., etc. But if we do the multiplier type one, which is IU, which is a multiplier type of arrangement, we can see it also goes from 0.8 to 1, which means, again, we can go from 400 amps to 1000 amps. But this multiplier gives you values which are slightly different, 0.80, 0.82, 0.84, etc., multiplied by whatever that is. So you could get values which are not pre-stepped if you had to do that. This is how close protection could be set to where you require it. It's even giving you values in between maybe set points. All right, so again, step one, that's how we're going to set it. Step two, we're going to look for instantaneous values. And again, this one goes 2 to 16 times. Of course, it even tells you don't set in that zone because there won't be a trip there. So look out for those type of things. Don't set it at some of the values where you think, oh, well, like this is 16, I want 18, and go put it in there. They probably don't function at all in any other area other than what they're set. They might have little notching points that you can see it or not. So again, we need to set this because if we look, that's times IR. Again, we won't go into the details here, but the instantaneous values have got to be at a value that are realistically set. Step three, so timing values. So anything that's in seconds is time. So if you look at TL, again, it goes 12 to 150. You can see this one is actually pretty much as it came out of the box where it was set at max. And unless you've got a full single motor, as we always say, you're not going to leave it there. If you really don't understand what you've got, rather do a fence hanging system here and put it in the middle. It's far better. Other thing on this particular time, and the other one said MCR, you'll notice here it's I squared T on and I squared T off. Now, off would be non-motor and on is motor, I believe. So again, depending what type of load you've got, you need to know where you're going to put this. And this is going to block the inrushes. We said additional settings. Now, there is space in here for additional settings, and you can see what is missing immediately on here is the G1 relay, which will give you ground fault. In fact, you do get a G1 and you get an E1 for earth leakages, and earth leakages in that case will be a much finer and more settable one in terms of earth leakage, but will require CTs based, the general CT to this. These ground fault relays you just plug in and it utilizes the CTs on the device itself. So that's effectively what you could see in going out to a job and where they need to be set. I would say that if you go to a site and you see everything still on the maximum, that's really concerning wherever you go. Don't go and be called to a site for I don't know, backup cleaning or, I don't know, some conservative type arrangement, and finding everything on maximum would be already a warning shot, unless, as we said, there's a single motor running on that particular thing. And that you're only going to find in very, very selected plants, odd mining applications, etc., where there's a huge pump or some form of motor where it's single motor driven. All right, so hopefully this ties in a little bit of the discussion we had on the electronic circuit breakers with something to actually look at. Now, my experience has been that many of the products on the marketplace are highly compatible with that approach, and I don't think you'll go far wrong if you just understand what those relays are. And although we've looked at air circuit breakers here, because they are kind of been doing these for many, many years now, you are getting electronic protection on smaller breakers, molded case type breakers. And you might have little dip switches that you have to arrange to ensure that the product, how can I say, runs compatibly with what you've got and what you'd like to use.